All right, ladies and gentlemen, we're going to be learning about 12.2, square root functions and radical equations. So we have a definition here. It's called the square root function. This is where the function of y equals the square root of x is the simplest square root function. The square root of x means the positive or principal square root of x. The range of y equals the square root of x is limited to z in all positive real numbers. The domain is also limited to 0 in all positive real numbers because square roots of negative numbers are not real numbers. So that's just a definition in this section, working with positive values and working with the domain limited to 0 in positive numbers along with the square roots. Let's go in to do some examples here in 12.2. In this problem, this is the square root, let me continue that square root, the square root of 2x minus 3 equals 4. Now, we want to get rid of this square root sign. In order to get rid of the square root sign, we need to square the left side, but whatever we do to one side, we have to do the same to the other. So we're going to square the right side. So, the square root of 2x minus 3 squared, that just becomes 2x minus 3. Equals 4 squared. 4 times 4 is 16. I'm going to continue simplifying this problem by solving for x. So I'm going to add 3 to the left, add 3 to the right. So I'm left with 2x equals 19. I still need to solve for x, so I'm going to take the inverse operation by dividing 2 to each side. So x is going to equal 9.5. And that is my answer. We've solved for x. Let's look at number 2. We have the square root of x minus 3, which is equal to 3. We want to solve for x, so we want to get rid of this radical sign, square root sign. To do that, we need to square the left side, but we also have to square the right side. The square root of x minus 3 squared is going to be x minus 3, which is equal to 3 squared is 9. Again, we're solving for x, so we're going to add 3 to the left, add 3 to the right, so x is going to equal 12. And that is my final answer. Let's continue here with some more problems. These are similar, but notice we're equal to x and not a value like we saw for in the last page. So 3, we have the square root of 4x plus 5 equals x. Again, we want to get rid of the radical sign, get rid of the square root sign, so we're going to square the left side, square the right side. And this left side becomes 4x plus 5 equal to x squared. Now what I want to do is I want to set this equal to 0. So I have x squared on the right, I have 4x plus 5 on the left. I'm going to take all of this and I'm going to move it over to the right side, and you'll see why. So I'm going to subtract 4x, subtract 5, so what I'm left with is 0 equals x squared minus 4x minus 5. Now notice now we have a polynomial and we have to figure out what x is going to be. So I'm going to factor out values to figure this out. X squared gives me x and x. What two factors gives me 5? But also adds to give me negative 4. Well, that's going to be 5 and 1. Whoops. 5 and 1. it's going to be a negative 5 and a positive 1. So we have x minus 5, x plus 1. So now to solve for x, I'm going to set each of these equal to 0. So x minus 5 equals 0, and x plus 1 equals 0. First, I'm going to add 5 to each side. So x equals 5. The next one, I'll subtract 1 to each side, so x equals negative 1. So I come up with x equals negative 1 and x equals 5, but these are not both of my answers here, because now what we have to do is we have to check each solution to make sure it is true to the original problem. Okay? So what I'm going to do is I'm actually going to erase everything here. So after solving for x, we said x equals 5 and x equals negative 1. So I'm going to go back in now and plug in x. I'm going to plug in 5 and negative 1 in for x to see which one's true. So here I have the square root of, I'll write this, x equals negative 1 and x equals 5. Let's plug in negative 1 for x first. So I have the square root of 4 times negative 1 plus 5. Will that equal negative 1? Well, let's see. 4 times negative 1 is going to give me negative 4 plus 5. So I have the square root of 1 equals negative 1. That is not true. So x equal to negative 1 does not make that a true situation. Let's now plug in 5 for x and see if that makes it true. So now I'll plug in the square root of 4 times x now is 5 plus 5. Will that be equal to x, which is 5? Well, let's see. 4 times 5 is 20. Plus 5. 20 plus 5 gives me the square root of 25. Is the square root of 25 5? It is. They equal one another. So my solution to number 3 is x equals 5 because they equal one another. Let's try another example of these. For number 4, we have the square root of 3x plus 4 equals x. I want to get rid of that square root sign on the left. So whatever I do to the left, I have to do to the right. So now I have 3x plus 4 equals x squared. Similar to the last problem, I want to set this equal to 0 to find my x's. So I'm going to bring my 3x plus 4 over to the right. So I'm going to subtract 3x and subtract 4 from the left. I'm also going to do that to the right side. So what I have here is x squared minus 3x minus 4 equals 0. I want to factor this out to set this equal to 0. So we have our parentheses. X squared gives me x and x. What two factors multiplied by each other gives me negative 4. But when we add them, gives me negative 3. Well, that's going to be 4 and 1. It's going to be a minus 4, and it's going to be a plus 1. So in my parentheses, I'm going to have x plus 1, x minus 4. So now once I have factored out my x squared minus 3x minus 4, I'm going to set that x plus 1 and x minus 4 equal to 0. So we have x plus 1 equals 0, x minus 4 equals 0. Subtract 1 to each side, oops, subtract 1, so I get x equals negative 1. Add 4 to each side, so I get x equals 4. Again, each of these are not my final answer because what we have to do now is go back into the original problem and make sure my left side is equal to my right side given my x's that I solved for. So let's see. Let's first plug in x equals negative 1, so I have the square root of 3 times x, which is negative 1, plus 4, and that needs to be equal to x, which is negative 1. 3 times negative 1 is negative 3 plus 4. Negative 3 plus 4 gives me gives me 1. Square root of 1 does not equal negative 1. So x equal to negative 1 does not work. Let's try x equals 4. So if I have the square root of 3 times x, which is 4, plus 4, does that equal 4? Let's see. 3 times 4 is 12. 12 plus 4 gives me 16, so I have the square root of 16. Does the square root of 16 give me 4? It does, which equals 4. So x equals 4 works. That is a solution right there. Last 3 problems here. Now we have solving for the following equations for x. So what I'm going to do here is notice I have x squared equals 200. I want to get rid of the x squared, so we take the square root of each side. So I have now x equals the square root of 200. I now need to think of what 2 factors makes 200. One of the factors has to be a perfect square number, so it's going to be 100 times 2. So x equals the square root of 100 times 2. 100 is a perfect square number. So when I take the square root of 100, we get plus or minus 10 times the square root. Since 2 is not a perfect square number, we leave that under the radical sign. So my final answer is x equals plus or minus 10 times the square root of 2. And that's the answer to number 5. Let's look at 6. We have x squared equals 5x plus 12, x squared equals 5 squared plus 12 squared. I'm going to take the square root of each side. The square root of x squared gives me x equals, under the radical sign, 5 squared gives me 25 plus 12 squared gives me 144. Now I'm going to add 12 plus 144. And when I add them, I get 169. So I have x equals the square root, don't forget the plus or minus, square root of 169. The square root of 169 is going to give me x equals 13, plus or minus 13. And that is my answer for 6. Last problem, 7. We have x squared equals y squared plus z to the third. I take the square root of the left side, take the square root of the right side. Square root of x squared gives me x, which equals y squared, just will be left as y squared, plus z to the third. And since we're working with just variables here and no numbers, this is going to be my final answer. When you take the square root,
Connor Bodewine, your line is leaving. Connor Bodewine, your line is leaving.
sorry about that interruption. So the final answer is going to be x equals the square root of y squared plus z squared, since you're working with variables here. So hopefully you took notes in this section. We are going to do some problems out of this section in class tomorrow.